Increased uptake of oxidized LDL by macrophages from type 2 diabetics is inhibited by polyamines, an advanced study. Patients with diabetes mellitus have an increased incidence of atherosclerotic cardiovascular disease. To date, considerable evidence supports a role for oxidative modified low-density lipoprotein, LDL, in the pathogenesis of atherosclerosis. The aim of this study was to evaluate the effect of polyamines putrescine, spermidine, and spermine on human LDL oxidation and to assess the ability of macrophages derived from type 2 diabetic patients to uptake ox-LDL. Polyamine effect was compared with alpha-tocopherol. 4 healthy subjects and 8 type 2 diabetic patients were included in this study. Data were expressed as the mean ST. Significance among experimental groups was calculated by one-way ANOVA test and 2K HSD test for multiple comparisons using the SPSS program. To characterize type 2 diabetic patients and non-diabetic subjects, laboratory tests were carried out. Glucose, glycated hemoglobin, HbA1c, triglycerides, low LDL, and high-density lipoproteins, HDL, and serum lipid peroxidation were measured in blood. The study was performed in 3 stages. For each stage, 10 experimental conditions comparing the effect of polyamines with alpha-tocopherol, 10 micron solutions, on LDL oxidation and the uptake of ox-LDL by macrophages were analyzed. MDA concentration was found to be significantly higher in type 2 diabetic patients compared to healthy subjects, 5.6 plus or minus 0.58 versus 2.66 plus or minus 0.31 microns MDA, respectively, P less than 0.05%. Of macrophages containing ox-LDL was determined by means of red-all staining. The uptake of ox-LDL by macrophages derived from diabetic patients was clear. The uptake of ox-LDL was inhibited when the oxidation was prevented by polyamines or tocopherol. Spermine showed high antioxidant capacity, 96.67 plus or minus 1.53% versus 25.67 plus or minus 2.30%, compared to tocopherol, 96.67 plus or minus 1.53% versus 47.00 plus or minus 7.20% at the concentration tested. In conclusion, polyamines, especially spermine, has a potent antioxidant effect compared to tocopherol on human LDL oxidation, followed by spermidine and putrescine. The results have clinical relevance in the diabetic complications and acknowledge on the role of polyamines as natural antioxidants. This research is not a clinical evaluation, rather a functional analysis utilizing clinical samples. Thank you for watching this video. Please subscribe our channel for watch more scientific research videos.